Okay, in this video, I'm going to go through the 2022 end of year Set 3 Express physics paper. I'm only going to go through question 12 to 14. The rest of the question, I think you can actually figure it out by discussing with your friend. So let's get right into section B. Okay, so for section B is about database question. Most of the question is actually from the data, not much on the content. There will also be one suggest question in this exam. So let's take a look. So first we ask you about the relationship between velocity and the wavelength, looking at this graph. So most of the answer are able to tell us that you can tell that the speed increases with the wavelength, but only a small minority actually take note that the gradient actually is decreasing. So when we talk about relationship, it is not just linear, non-linear. You also have to tell us how is the gradient like. Okay, so you can either tell us that the gradient is dropping, or if you are more comfortable with mathematics, you can say that the speed increases with the wavelength, but the increase is at a decreasing rate, meaning that if I look at this interval and if I compare it with this interval, let me use another color, right? So you can see that the speed from here to here, the increment is given by this red line, right? And when I look at the same interval, you can see that the increment is represented by this red line. And if you continue to do this, right, you can see that the red line is actually getting shorter and shorter and shorter until whereby the increase is almost not possible to spot. So we call this particular increase, the increase here is getting lesser and lesser. So we say that the increase is at a decreasing rate. Okay, but ultimately the speed still increases. It's just that each increase is getting less. Okay, so if you are not so comfortable with this concept, just break the whole concept into two parts. That the general trend is that the speed increases with wavelength, and this trend has a gradient that is decreasing, full stop. Then you won't have so much adjective to play with. Just keep it simple. One noun, one adjective, done. Part B I'm not going to cover because most of you get it correct anyway. For part 2, many of you got it wrong because you didn't read the question. It actually says that when lambda is 37.5, which corresponds to this point, you can ignore this point. So by ignoring the point, you can actually see that the dots over here, right, is actually aligned very nicely for you to draw a best fit straight line. So if you do that, you will get the correct answer. For part 3, we just want to check how many of you are still not comfortable dealing with y equals to mx plus c. So we give you this particular formula, and because the graph given to you, if you look here, the graph is actually v square is versus lambda. So if your graph is v square versus lambda, what you should try to do is that you should make the left hand side of the equation to be v square, because this is your y and this is your x. So make the left hand side v square, and to make the left hand side v square is pretty simple. You just square both sides of the expression and you will be able to get v square on the left side. What you have on the right side is just this chunk of things, and now your expression will look like the standard line equation, which is y equals to mx plus c. And you can see here, v square will take up your y position, lambda will take up your x position. This means that your gradient of your graph will be a square. So a square here doesn't mean acceleration. It is just a random parameter that we introduce. It is also not your frequency. It is just something that we make up. Okay, so the gradient of this graph basically will be represented by your a square. Okay, for part 4 you can actually find the gradient. It is very straightforward. We even give you some slack. You don't need to derive the unit, right? And we tell you exactly how many SF, so you don't need to read till the half smaller square. For part C, it is a suggest question. So a suggest question usually is not hard, right? In fact, we are simply asking you to give us two factors, right? We didn't ask you to give us y, but for my class in particular, most of them get 0 because they try to explain what the wave push the molecule affecting the wavefront or wavelength or something like that. Don't need. All you need to tell us is either one or two of these four things, right? The speed of the wind will make the wave go faster, things like that. You can even use your geography knowledge, which is the reach of the wind, we will accept. So if you have doubts in your answer, you feel that it is correct, it should be accepted, please bring it up to your teachers. Okay, for 13 part A, we are giving you a very simple ray diagram. Okay, in case you are not from my class, the way I teach my class is that if you are asked to sketch a ray diagram and you are those that are not very confident, what you can do is you can quickly sketch out a standard ray diagram model. So a standard ray diagram model basically looks something like that. You can just anyhow sketch. So for me, I don't really care where is my image. I just make like, okay, there will be one ray that cuts the optical center, then there will be one ray parallel to the principal axis, and then somehow it will cut, right? So the converging point here will give you the image. So I'm just anyhow sketching one standard model. And from this standard model, right, what I can tell is that there will be one point here, 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 one point here. So basically, I turn my question, right, into those, number and dot diagram. You can see that in this question, sorry, I should call this 1, 2, 3, 4, 5, 6. I have 7 dots, right? I link them together. It forms this shape. So now I have this question. How many dots do I have? Well, I have dot number 1. I have dot number 2. I don't know what is P, but I have dot number 7. I have dot number 6. So what I ask myself is now, okay, now I have point 1, point 2, point 6, and point 7. And then I look at my standard model. I ask myself, which 2 points can connect and form a line? And quickly it emerges out very clearly that point number 2 and point number 7 forms a line on my standard model. So what I do is that I will now use my ruler and I will draw a line from point 2 to point 7, and then I see what happened. So once I draw this line, right, I can see that I have done this green line, right? And I can see that by drawing this green line, I can actually expose point number 4. So I can see that point number 4 is here, and when I look at my standard model, oh, point number 4 is actually my lens. So now I have located my lens, and I'm going to draw it right here. This is my lens. And then after I draw my lens, what else can I expose? Oh, then I see that I can actually draw point number 3 to point number 2, because point number 3 and point number 2 should form a horizontal line. So then I can then now draw my point number 2. I draw a horizontal line towards my lens, and I will be able to form point number 3. Once I have point number 3, I can see from this diagram, my standard model, that point 3 and point 7 will also form a line, right? So point 3 and point 7 forms a line. So I draw this, right? And if I draw point 3 and point 7, basically I will expose point 5. And point 5 would be my focal point. So now I have my focal point, and I can see that this point P is just there to distract me. That's all, right? So you can see by doing this, I don't really need to memorize much. I don't need to use my brain too much. I'm just comparing my standard model with whatever I have from the question. So if you can see from the question, I have 1, 2, 6, 7, and I'm just using that to form whatever shape I have. Yeah. Part 1, you will be able to do that now with your own correction. Point 2 as well. For point 3, read your notes. You'll be able to tell how you should increase the size of the image. Go and do your correction. I will check. Then for point 4, what happened is that the object is now placed at point P. So now I know why point P is there. So now if I look at this, if I go and place my object at P, basically my object now is placed within one focal length, right? This is within 1F. And if I look at my notes, I would know that when my object is placed within 1F, it is going to form an image, but this image will be one that is virtual. And whenever you have virtual, you will have upright. These two always come as a pair, right? If this is real, then this will be inverted. It is always a pair. Then for the image property, when you place the object within 1F, you should get an image that is virtual, upright, and magnified. So this has to do with your content knowledge. If you do not know the answer to this question, this video will not be a video that we kept for you. Go and read up on your notes. Okay, if I'm right, it should be under content library. I think it is under the light chapter. So you all need to go and look for it. Yep, here, right? So if you go and look at your worksheet 12.3, you will actually find this diagram, and in it you can see that if your image is placed here within 1F, you are going to get enlarged, virtual, and upright image. Okay, as to why, actually there's an explanation at the bottom. You can take a look at it, and if you are in doubt still, please don't let the doubt snowball and fester. Go and approach your teacher and get it clear. Okay, for part B, it is still a optic question. They actually tells you that this glass has an index of 1.5. So whenever I get the refractive index, the first thing I am going to check is that I want to know what is the critical angle. Because once I know the critical angle, I would know whether the light will get TIR or that it will get refracted out. So by having this formula, sine C, which is the sine of the critical angle, will be equals to a ratio between the refractive index of the lower medium over the refractive index of a higher medium. So in this case, the lower medium in this case will be air, and the higher medium will be glass. So I sub in the value. This is the critical angle that I'm finding, and I can see that, oh, at R, my incident angle is just 15. So this guy is actually lower than your critical angle. And when the incident angle is lower than the critical angle, I will know that it will just get refracted out. So that is my answer, right? Because the angle of incident is less than the critical angle, I will know that the ray will refract out. And how is the refraction is going to be like? Is bending away from the normal. And I have to explain. So why it bend away from the normal? Well, because the ray will speed up as it enter air, right? Then for part 2, why is it that I want to have actually a high index medium for the optical fiber? That is because if your refractive index is high, the critical angle will become actually very small. Okay, if you don't believe me, you can try do a substitution here. You can actually change this to a bigger value, for example 15, and then you can see how the critical angle change. Okay, so what is so beneficial about having a small critical angle? That is because if you have a small critical angle, it means that there will be a huge range of incident angle that will give you TIR. So for example, if I have two cases, case 1 versus case 2, if now my critical angle for case 1 is, let's say 40 degree, and my critical angle for case 2 is 10 degree, it means that if I have angle I that is let's say 12 degree, right? If I have an incident angle of 12 degree, you can see that in case 2, my incident angle is lower than the critical angle, so you won't have any TIR. But for case 2, if I have an incident angle of 12 and my critical angle is 10, it means that I will have TIR. And in an optical fiber, you need TIR because in an optical fiber, when light enters the optical fiber, you need TIR to actually for the light to be trapped within the optical fiber. Otherwise, like in case 1, if your optical fiber doesn't allow you to have TIR, the light when it enters into the optical fiber at this point, if there's no TIR, the light will actually escape. And basically your light, right, is going to be your theta. So if your light ray actually escape from the optical fiber, basically you are going to lose the data. So therefore, when it comes to a context of optical fiber, you want TIR. So therefore, with a smaller critical angle, you are going to get more TIR to happen. And because and why is it desirable? Because with more TIR happening, you will have less data loss. Okay. Okay, now for the last question is kinematic. It is actually very straightforward. Okay, because it is actually a free fall. You can tell it from here. Air resistance is negligible. So when air resistance is negligible, you're going to get a constant acceleration, which is g. And because the object is falling, it must speed up, right? And it travels downward. Okay, for your 14B, if you got it wrong, I'm really disappointed. You are in urgent need of help. Okay, so for 14B, you are supposed to calculate the final speed right before it hits the ground. You can actually get the hint from here. It actually falls for 5.0 seconds before hitting the ground. So because of that, you would know that T should be equals to 5. And like what I shared in my previous video for forces, how do you decide which is positive and negative? You look at the initial direction of motion. So in this case, initially the ball is falling. So because the ball is falling, we will take the downward direction as positive. So because of that, your gravitational acceleration is also downward. It is positive 10. You started dropping the ball from rest. So you can see here, you release the ball from rest. So because you release the ball from rest, your initial velocity will be 0. And like I said from the question, it falls for 5.0 seconds before hitting the ground. So you would know that time is 5. So by doing this formula, you are going to get 50 meters per second. Now, once you have set the downward direction as positive, please maintain it to all the parts of the question. So in the next question, you were told that it actually rebound to a height of 45. So when you rebound, basically at the time of rebound, your velocity is going to be 0. And they actually tell you the rebound velocity right after it hits the ground, meaning that u is going to be minus 30. Now, why is it minus? Because initially you take downward as positive, so when the ball rebound, it rebound upwards. So when it rebound upwards is our negative direction. That's why you have the initial velocity minus 30. So you don't even need to sketch a VT graph. You can use back A equals to V minus U over T. A is still downwards, right? Even though the ball is rebounding upwards, the gravitational acceleration in this case is still downwards. So we remain at positive 10. Now the initial velocity is going to be minus 30. So minus will give you a plus. If you do your algebra correctly, you will get T equals to 3.0. Okay. So last but not least, you are supposed to sketch the VT graph. So very simple. Let's collate all the information you have. You know that at time equals to 0, it falls from rest. So it should start from 0, 0, right? Then you know that the ball actually the ball actually falls for 5 seconds, right? Here, the ball falls for 5 seconds. So it falls for 5 seconds, and as it falls towards the ground after 5 seconds, the speed actually becomes 50, right? So it becomes 50. Then at the 5-second mark, it also hit the ground, right? And after it hit the ground, within the same 5 seconds, it actually rebound, and it rebound upwards 30 meters per second, right? So it rebound 30 meter per second after it hits the ground. So this is before it hit, then it hit, then after it hit, right, in the same 5th second. Then after that it travels upward, and as we calculated, it travels a total of 3 seconds before reaching the maximum height, right? Before reaching the maximum height. So I know if this plus 3 will be 8, it will reach maximum height. So I have all these coordinates done. So time equals to 0, v is 0, right? Then after that, at the 5th seconds, my velocity is 50. So I have this. Then after that, it is going to be a straight line because my acceleration is constant, right? I know that this guy is going to be a straight line graph, right? Because your acceleration is constant, right? So if acceleration is constant, then at t equals to 8, right? T equals to 8, maybe here, I'm going to rest here. So if acceleration is constant, meaning that I must keep my gradient constant, right? So I'm going to take a ruler, and I'm going to use this line as my reference to draw this. So I'm going to draw this. Then I will go and dot 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 dot, dot, and I know here will be my minus 30, right? And I can tell that this gradient and this gradient is constant because it's going to be a straight line graph. A is constant throughout the motion, right? Okay, so that is all. Please do your correction, and if you still have doubt, please don't hesitate. Don't let it fester and wait until set 4 end of year and then you panic. Go and clear your doubts ASAP. Okay, remember to like and subscribe so that I can upload more videos to YouTube.